equals price feed dot decimals. And what we can do now is we can return both of these. So this actually needs to return a uint 256 and another uint 256 for the decimals here. And we can do return. We can return both of these. So we'll do a uint 256 price. We'll wrap that price into a uint 256. And then we also need to wrap the decimals in a uint 256. Since decimals actually returns a uint 8. So we'll return the price and the decimals. All right, now we're cooking. Now we can go ahead and start scrolling back up and adding all this stuff in. So we can say uint 256 price, uint 256 decimals equals this get token value that we just created right here. And then we can just have this return staking balance of the token of the user times the price. We're going to do some interesting math here, divided by those decimals. 10 raised to decimals. Whew. And I know there's a little bit of math here, right? And so you might be going, wait, what are we doing here? Wrap that up like that, just so that we're absolutely certain we're doing correct order of operations here. So we're taking the amount of token that the user has staked, right? Let's say, for example, 10 DAI. And we're taking the price of that DAI. Maybe we have all of our contracts, all of these tokens get converted back to the USD price. So we have DAI USD. Or actually, better yet, let's say we have 10 ETH, right? Our price feed contract is going to be ETH USD. Let's say the price is $100 per USD. So this first bit is we're going to do that 10 ETH times $100. So we're going to do 10 times 100, which is going to equal to 1,000 value. The only thing is we also have to divide by the decimals. So our staking balance is going to be in 18 decimals. So it's going to be 1, 2, 3, 4, 5, 6, 7, 8. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. But let's say our ETHUSD only has 8. So 1, 2, 3, 4, 5, 6, 7, 8. So we need to multiply these first and then divide by the decimals. That way we can arrive at a price that actually makes sense. It's going to be a function that we're definitely going to need to test to make sure that we're doing everything right, so that we're doing all the math correctly. But okay, now that we have this user single token value, we go ahead and come back up to our user total value, and we can literally finish this function by just calling return total value. And then we can pull up to our issue tokens. Now that we have the total value that this user has actually locked, we can just transfer the amount of tokens that they have in total value. So we can say dap token dot transfer this recipient. We can transfer them the total value, right? We'll say however much they have in total value staked on our platform, we'll issue them as a reward. And that is our issue tokens function. We are making great progress. All right, so we have a way to stake. Done. We have a way to issue. Done. We have a way to get value, or just get value. Done. We've added a way to add allowed tokens, and all we have to do now is add some way to unstake the tokens. So let's go ahead and create this function. I'm going to make it right underneath the stake token one. We'll do function unstake tokens. We'll pass it the token address. We'll make this a public function so anybody can call this. The first thing we're going to want to do is fetch the staking balance. How much of this token does this user have? So we'll say uint 256 balance equals staking balance of the token from message.sender. And we're going to require the balance is greater than 0. Otherwise, we'll say staking balance cannot be 0. And then we're going to do a transfer. So we'll do IERC20 of the token dot transfer message.sender balance. Once we actually transfer the token, we'll do staking balance of this token of message.sender, we're going to update this balance to now be 0, right? Because we're going to transfer the entire balance here. And then we're going to update how many of those unique tokens that they have. Now, a quick note here, later on, we're going to learn about reentrancy attacks. So at some point, come back here and figure out, hey, is this vulnerable to reentrancy attacks? So we'll say unique token staked of message.sender is going to equal unique token staked message.sender -1. Now, the last thing that we could do is we probably should actually update our stakers array to remove this person if they no longer have anything staked. This is a little bit sloppy, but we're just going to skip doing that for the time being. However, if you want to go back and add the functionality to remove the stakers from the stakers list as they unstake, please go for it. It's not a big deal if we don't actually do this because our issue tokens function is actually going to check to see how much they actually have staked. And if they don't have anything staked, then they're not going to get sent any tokens. But all right, that's basically all of the functionality here. Let's just try a quick sanity check with the Brownie compile. Whoops, I forgot to add v0.8 in here. Let's try again. That little bit. This needs to be token, and this needs to be user. Whoops. And then it looks like I did the same thing down here. This is actually staking balance. Let's try it again. And perfect. Everything is at least compiling correctly. Just because it's compiling correctly, though, doesn't necessarily mean that we're doing everything correctly. So this is fantastic. Typically now we'd want to go ahead and start doing our tests. I'm actually going to go ahead and build one of our scripts first. The reason I'm going to build one of the scripts first is because I'm going to use my deploy script pretty regularly in my tests. I'm going to use it as part of my testing. This way I can also test some of my scripts as well in addition to the contracts. So let's go ahead and make our deploy script. So let's create a new file in here. We'll call it deploy.py. We'll also create an init.py for those of you who want older versions of Python. And let's go ahead and do this. So we're going to have a main function in here. And in our main function, we're actually just going to call deploy token farm and dep token. And then we're going to have a function def deploy token farm and dep token. Right, and I should be able to run scripts deploy.py. And great, everything's compiling right, and we're running our scripts here. So first thing that we're going to want to do, as always, is get our account. And I am going to copy a couple of those helpful scripts from our past projects. So I'm actually going to pull up our NFT demo that we did. So I'm actually going to go to our Chainlink mix that we did. And I'm going to grab our helpful scripts. Remember, we can always jump onto the Chainlink mix here and we can just grab some of the scripts from here. So we could go to scripts, helpful scripts, and just copy paste this whole thing, or just grab it like I did, right? These are going to be those exact same scripts that we built previously. So now we have our helpful scripts in here, right? We're going to have this contract to mock for running our tests. We have get account so that we can get our accounts easily. We have encode function data, which we're not going to have to work with since we're not doing upgradable contracts, but we have it here anyways. We have upgrade, which we're also not going to use, but we have it here anyways. We have get contract, which returns mocks if they're not already deployed, or it just returns whatever contract that we're looking for. And then of course we have our deploy mocks script here. So now we can do from scripts.helpful scripts import get account. And perfect, we can get our account like that, no problem now. And now we're going to want to start deploying some contracts. So we're going to deploy that dap token first. So we'll do from Brownie, import dap token. And we'll do dap token equals dap token dot deploy. And this takes no parameters, so we can just do from account. Then we're going to want to deploy our token farm. So we could say token farm equals token farm dot deploy. And this takes one parameter, which is the dap token address, right? Because we need that address so we can give it out as a reward. So we're going to say dap token dot address. We'll do a comma, and then we'll say from account. we'll need to import this from Brownie as well. And while we're here, we might as well add some publish source bits on here. So we could say publish source equals config. We'll grab this from the config. Networks, do network.show active, verify. We'll grab network from Brownie. We'll grab config from Brownie. And in our config here, let's do networks. We'll add development. We'll set the verify here to be false. And then we're going to work with the Coven chain. So we'll say Coven. Verify will also be false. Actually, Coven will be true. And then we'll do a persistent ganache. Our verify for this will be false. And I'm even just going to put this up here so that all these ganache chains are kind of with each other. So we'll verify in Coven, but we won't on development or ganache. Now, once we've deployed this token farm contract, we need a couple things, right? We're going to need to send this some dApp tokens, right? We're going to need to send pretty much all the dApp tokens so that I can actually give those tokens out as a reward. So we're going to want to do a transaction is going to equal to dApp token dot transfer. We'll send it to the token farm dot address. And then we have to choose how much we're going to send, and we'll send the total supply. But we'll keep a little bit for ourselves so we can do some testing, and so just in case. So we'll also do minus kept balance, some static kept balance, which we can say add at the top. We'll say the kept balance is, let's keep like 100. So this will be equal to web3.2way 100 ether. So we'll do from web3 import web3. So in our transfer, we'll do dApp token.total supply minus the kept balance. And then of course, we're gonna have to do a from account. So now we're sending our token farm basically 99.9% of the total supply of this dApp token so that it has this token to actually give out as a reward. We'll do a tx.wait. We'll wait for one block confirmation there. Now what do we want to do? Well, if we look at our token farm, we know at our stake tokens function, we can only stake tokens that are allowed. And each one of these tokens also is going to need to have some price feed associated with it, right? In our token price feed mapping. So we're going to have to add those. So what we're going to want to do is we're going to want to create a function called add allowed tokens. And what this is going to do, it's going to add the tokens that we want to allow, and it's going to give them a price feed contract associated with them. So let's create this function. We'll call it def add allowed tokens. And this is going to take a couple things. We're going to want to take that token farm because we're going to need to call the add allowed tokens function on it. We're going to take a dictionary of allowed tokens, and this is going to be the names. This is going to be a dictionary of the different token addresses and their associated price feeds. So we're just going to price everything in USD so that we can figure out the value of everything in USD. And then last, of course, we're going to need an account. For now, I'm just going to do pass here. Let's look at the different inputs that we're going to put into this. So obviously we're going to do token farm, but then we're going to need to make this dictionary of allowed tokens. So we're going to need the address of the different tokens that we want to have. Now, how do we get the addresses of the different tokens that we're going to use? And what are the tokens that we're even going to use here? For simplicity, we're just going to start with 3 tokens. We're going to allow our platform to allow 3 different tokens to be staked. We'll use the dApp token as one. We use WETH token or wrapped ETH because that's pretty much a standard in most smart contract platforms. And then we're also going to use an FAU token, which stands for faucet token. And we're going to pretend that this faucet token is DAI or DAI. The reason we're going to use this faucet token is because there's this erc20faucet.com, which allows us to get this fake faucet token. We can get unlimited amounts of this faucet token on different testnets. We're going to pretend that this faucet token is going to be DAI, right? So FAU token / DAI. So how do we actually get these addresses? Well, dApp token, we know. WETH token, what we can do in our config is we can actually add those addresses here. So for Coven, the WETH token address is going to be this right here, which again, you can go check this out And you can find it on Etherscan. You can write your own if you want. We're just going to use this already deployed one on Coven. FAU token, which is going to be this token here, which I know is going to be this address right here. And if you want, you can come here and grab your address, paste it into this erc20faucet.com, put an amount of 10 in here, we'll connect to MetaMask. Oh, and even tells us the token address right here, which we can just copy paste. We can do mint free tokens, confirm. Great, it says success. If we don't already have it, we can take this token address, go to our MetaMask, assets, add token, paste it in. I've already got it. We can see right now I have 5 FAU. Once this confirms, I'll have an additional 10, and now you can see 15 here. This is going to be this FAU token that we're going to use. We have WETH here, and then we know what the DApp token address is going to be from when we deploy it here. Now we could do, again, we could do the config, networks, etc., and just always get it from our config. Or we could use our get contract method that we grab from our helpful scripts, which will deploy a mock WETH token. It doesn't exist in one of these. And that's what we want, because we're going to want to test this locally. So we're going to want to deploy our own fake WETH token. So we'll say the WETH token equals get contract WETH token. And then the FAU token, it's going to be get contract FAU token. And remember, what we put in here, our string that we put in here, needs to match our string in our config. Now, in order for this get contract to work for WETH token and the FAU token, we're actually going to have to modify our helpful scripts here. So if we copied and pasted it directly from our Chainlink mix, this is basically what we're going to have here. We're importing all of our mocks, which we can go ahead and copy paste these as well from the Chainlink mix, our test, our mock contracts here. We have some forking implementations. We have contracts to mock, which tells us based off of the key, what token or what contract we're going to use to mock. We have get account, which we use all the time. In order for us to do this contract to mock correctly, we're going to have to mock WETH and FAU. And actually, we don't even need all these in here. We don't even need this whole contract to mock. In fact, we can get rid of mock Oracle. We can get rid of VRF coordinator, and we can even get rid of the link token for this. We do need this SDUSD price feed later on, so I'm just going to leave it in here for now. We definitely do need, though, FAU token, which is going to be mocked to something, and we need WETH token, which was going to be mocked to something else. So what are these tokens going to be mocked to? Well, they're each an ERC20 mock, but we want to give them kind of their own identity. So what we're going to do is we're actually going to make a mock ERC20 for both FAU and for WETH. So we're going to come in here, we're going to do new file. We'll call it mockDie.sol. And this is going to mock that FAU token. So it could be mockDie, it could be mock FAU, whatever we want it to be. And we're just going to make this a basic ERC20. So we'll do pragma, solidity, 0.8.0. We'll import at open Zeppelin contracts token ERC20, ERC20.sol. Obviously, this is going to look very familiar. This should spell pragma, not whatever I just spelled. This is going to look really similar to that DApp token. So now we can call it contract mockDie is ERC20, and we'll do constructor public ERC20 mockDie will be the name of this, and the symbol will be die. And perfect. And that's all we need. We'll copy this whole thing, and then we'll do the same thing for mockweth.sol. We'll paste this whole thing in here, and we'll just change the name. We'll call this mockweth, it's ERC20, mockweth, and this will be WETH token. Great. So now that we have those mocks in here, we can change FAU token to mockDie and WETH token to mockweth. We can import those from Brownie, and in fact, we can get rid of the mock Oracle here and the VRF coordinator, and instead we'll do mockDie and mockWETH. Now, of course, since we have DIUSD price feed and ETHUSD price feed, we're going to make sure we have these in our mocks here. And then we're also going to have to deploy these in our deploy mocks script below. So if we scroll down to deploy mocks, we can see this is what it currently has, which is pulling directly from the Chainlink mix. So we can just go ahead, delete the VRF coordinator mock and the mock Oracle, and instead we'll deploy that mock WETH and that mock die. So we'll do print deploying mock die token equals mock die dot deploy from account, and then we'll do print f statement deployed to die token dot address, and then we'll do print deploying mock weth, and then we'll do weth token equals mock weth dot deploy. We'll say from account, and then we'll print deployed to. This will be another printf with token dot address. Now, additionally, we have our ETHUSD price feed left over from the Chainlink mix. We also need this DAI-USD price feed. So we can go ahead in here. We'll add DAI-USD price feed, and we'll set this as a mock v3 aggregator. We could do is we could parameterize this up so that the mock v3 aggregator takes maybe some different decimals, a different initial value, so that these could be different. But for the sake of testing, we're just going to leave them being the same here. So great. So we have the address of the weth token. We have the addresses of the FAU token. And if those don't exist on the network we're working on, we're going to deploy a mock. So now that we have all these addresses, we can do a dictionary of allowed tokens is going to be equal to this dictionary that we make. So we're just going to route each one of these contracts, like the DApp token, to its equivalent price feed. For the DApp token, we're just going to say that the DApp is going to be equal to DAI. We're going to say the FAU token is also equal to DAI, and our weth token, of course, is going to be equal to ETH. So we're going to want to get a DAI-USD price feed, another DAI-USD price feed, and an ETH-USD price feed. So in our config, we can add DAI-USD price feed. And since we're going to be doing our integration tests on Kovan here, we'll come to the Chainlink docs. We'll go to Ethereum price feeds. We're on Kovan. And we'll scroll down to DAI-USD, which is this address right here. We'll pop that in. And then we'll also want the ETH-USD price feed, which we'll also go grab that from here on the Kovan network, and we'll grab that from right here, and we'll paste it in. So now to complete this dict, we can do this get contract again, and we'll deploy mock price feeds if they don't exist. So now we can just do get contract DAI-USD price feed. FAU token is also going to be DAI-USD price feed, and then our weth token is going to be ETH-USD price feed. And awesome, now we have our dictionary of allowed tokens that we can pass to our add allowed tokens. This will map the tokens and their addresses with their associated price feeds so that we can get them all to equal the same value in our contracts. So we can go ahead and create this function called add allowed tokens. We'll pass it this token farm, we'll pass it the dictionary of allowed tokens, and then of course, we'll pass it the account. Now in our add allowed tokens function, we're going to loop through all these different tokens and call the add allowed tokens function on it. So we're going to do for each token in the dictionary of allowed tokens. We're going to do token farm dot add allowed tokens, and we'll do the token dot address, and we'll do from account. We'll say add tx equals that. We'll do add tx dot wait 1. Then we're going to call this set price feed contract. So we're actually going to set the price feed associated with that token. So we'll do set tx equals token farm dot set price feed contract. And we'll do token dot address, the dictionary of allowed tokens of that token that we're for looping, and then of course from account. And we'll do set tx.wait 1, and then we'll just return the token farm. But we probably don't have to return anything. And great, that deploy script looks pretty good. And in fact, we're going to end our deploy script here with returning the token farm and the DApp token. This way we can actually use this deploy script in our tests. So I'm just going to do a quick little zoom out and we can see our wonderful deploy script right here. And awesome, it looks like we have just about everything here. Let's give this an initial test on a local ganache chain. See if our mocks all work, see if everything at least makes sense. We can call our functions. Awesome, it looks like we can call all of our functions and we can deploy our mocks and the mocking is working at least somewhat correctly here. This is great. We'll zoom out a little bit here. We've got our deploy scripts. We've got our add allowed token scripts. We've got all of our mock contracts added under tests. Things are looking good. Now, what do we want to do here? Well, of course, we want to run some tests. We want to make sure our contract is actually going to do what we say it's going to do. You guys ready? Let's jump into it. So in our tests, let's make a new folder called unit. We'll add a new file. We'll call it test token farm.py. Let's do some tests. Now, ideally, we would also write some tests for our DApp token. However, we're going to skip over those because we're basically just doing OpenZeppelin's implementation. But in a full-scale production here, you probably would want to write some tests on your tokens as well. So let's get into this. Let's look at our token farm and see what we need to test. Remember, ideally, every piece of code in our smart contract here should be tested in some form or another. So with that in mind, let's get started. So one of the first functions that we see is set price feed contract. So let's make a test for that. So we'll do def test set price feed contract. And we're literally going to test just this one function. So how do we test that? Well, first, let's make sure we're on a local network, right? Because we only want to be doing this on our local network since this is one of our unit tests. So in our arrange stage, we're going to do if network.showActive is not in local blockchain environments. Then we're going to run pytest.skip and say only for local testing. Of course, we got a number of pieces here that we need to import. We're going to have to do from Brownie, import network. We're going to do from scripts.helpfulscripts, import local blockchain environments, and then we're going to import pytest. All right, so now we're going to get an account to make these transactions. We'll say account equals get account, and let's grab that from our helpful scripts as well. So now we have an account we can use. Let's even grab a non-owner account. So we'll say non-owner equals get account, and we'll do index equals 1. This will give us a different account rather than this account, and we'll use this to check some only owner functions. And then what we're going to do is we're going to get the token farm and the DApp token based off of our deploy script. So we're going to use this deploy token farm and DApp token. And we're going to import that by saying from scripts.deploy import deploy token farm and DApp token. And we're just going to call this function in our test right here. So we're going to say token farm DApp token equals deploy token farm and DApp token. Awesome. This is how we're going to do this a lot, this arrange step for a lot of these tests here, because this is how we're going to set them up. We could even hypothetically turn this into a conf test or into a wrapper if we wanted to, but we're just going to leave it in here like this for now. Now we can move on to our act phase. So we're going to want to do token farm dot set price feed contract. Because remember, this is what we're testing right now, and we're going to use a token and a price feed address. So we use the DApp token dot address. We'll use get contract to actually get an ETHUSD price feed address, which we can also grab from our helpful scripts, get contract. An important note here, if you try to set a contract as an address parameter like this, Brownie will know, okay, that you're looking for an address instead of the actual contract. In any case, then we'll do from account. Save it and it reshifts over here. Now, this should work perfectly. So we're going to assert this. We're going to move into our assert stage, right? If we check our price feed mapping, this should now be updated. So we can do assert token farm dot token price feed mapping. And remember, token price feed mapping is an address to an address. So we'll say dap token dot address. This should be equal to get contract of ETHUSD price feed. This should be updated with exactly what get contract of ETHUSD price feed returns. In fact, we can even make this a little bit better. Copy this. We'll say price feed address equals get contract, and then we'll pop this in here, and we'll pop this here. That way now we're just using this single variable for both. All right, that's our first test. Let's run it. Brownie test. This will run the whole test suite. And we're passing. Awesome. Now, let's also do a test to make sure that non-owners can't call this function. We want to make sure that somebody other than the owner who deployed this, right? Because deploy token farm and dap token is going to be run by get account. We want to make sure that somebody else can't call this function. So we'll do with pytest.raises exceptions.virtual machine error. Oh, excuse me for that getting in the way. And then we'll try to call this exact same function here, right? We can even just copy paste it, but instead we'll call it from non-owner, right? And then we do also have to import exceptions from Brownie. So this should also pass. It's expecting this contract call to actually revert. So let's try this. Perfect, it passes, right? And we can double check to make sure that this pytest.raises is working, because what if we did account here, right? This now should fail, because this isn't going to revert. And that's exactly what happens. Perfect. So we can leave this as non-owner. And our first test is looking great. Let's even zoom out just a hair here. We can sleep easy that this function is going to work as we intended. Isn't that a wonderful feeling? Yes, it is. Great. Let's move on. So let's look at our token farm. What's the next function? Aha. Issue tokens. All right, great. Let's write some tests for issue tokens. So what are we going to do? Def test issue tokens. So how are we actually going to do this? Well, in order to test issuing tokens, we actually need to stake some tokens first. So for now, I'm actually just going to do pass here. And before we test issuing the staking tokens, we need to write a test for staking those tokens, right? Because in order to issue tokens, you need to have some tokens staked. So let's write a test stake tokens first, and then we'll write this test issue tokens. So we'll do def test stake tokens. Now let's set this up. So we're going to copy this bit here, because we are going to be working on a local network with this. We'll do account equals get account, and then we'll go ahead and deploy the token farm and the dap token. So this initial bit is going to be exactly the same, making sure we're on a local network, getting the account, deploying the token farm and the dap token. So now let's move into the act phase. Let's go ahead and act. Let's go ahead and actually send some tokens to our token farm. So first, we obviously need to call approve on the dap token contract. So we'll do dap token dot approve to the token farm dot address. And again, you can see, and again, we can go to the Open Zeppelin docs to figure out what the parameters of this are, but it's going to be an address and it's going to be some amount, and then obviously from account. Now I put a couple question marks here because we're going to constantly be using an amount, right? We're going to be using an amount staked for a lot of our tests here. So what we're going to do is we're actually going to turn that into a fixture. We're going to call it amount staked. And we're going to define this in our conf test folder. So we're going to make our conf test file. So in here, we're going to do new file, conftest.py, and whoops, it's in the wrong directory. So we're going to go cd tests, unit, we're going to do move conftest.py down one directory, and it should be in here now. If that didn't work, you should be able to drag and drop it into tests. You just want to pull it out of unit is what we're doing here, right? Just want to get it so that it's just in this test directory here. In any case, in our conftest.py, we're going to create our first fixture. So we're going to do @pytest.fixture. We'll do def amount staked, and then we're just going to return web3.2way 1 ether. Now, of course, we need to import pytest here. Then we're going to need to import. Then we're going to do from web3, import web3, and now it saves perfectly. So now we can use this amount staked fixture as basically a static variable, right? We could have done at the top, we could do something like amount staked equals, that exact same thing, but we're going to get into the habit of working with these fixtures. So we have our def test stake tokens, and we're going to pass it this amount staked fixture. PyTest and Brownie will automatically grab all this stuff from the conftest folder and put it into here. So now we can just use amount staked as a parameter in our test here. So once we approve, we can then do token farm dot stake tokens. We can now call our stake tokens function right here. And it takes an amount and then a token address. So of course, we're going to do amount staked as the amount, and then we'll do dep token address as the address, and of course, from account. And perfect. This is going to be our basic action of testing the staking functionality. So we can go ahead and down here and move into our assert phase, and we can just assert a number of things, right? We can do a little bracket here. We're going to do a couple of things here. We're going to assert the token farm that staking balance of dap token dot address of account dot address equals amount staked. So let's talk about this really quickly. What is this actually doing? So if we go to our token farm, we know that we have this mapping called staking balance. And this is a mapping of a mapping, right? So we need to actually pass two variables, the first address and then the second address, to get this amount. This is how you do that syntactically with Brownie. You just pass it as additional parameters in here. So we pass the dap token address, which is going to be the token address here, and then the account address, which is going to be the address here. And perfect. So we can even run this by doing Brownie test -k test stake tokens. And great, looks like that passed perfectly. But we have a couple of other assertions to make, right? Because if we look at our stake tokens function, it does a lot of things. So let's check all of these and make sure that they all are working correctly. So we'll also assert that the token farm dot unique token staked of account dot address is going to be equal to 1, right? This is going to be the first token, so it should have a unique token staked. We should also assert that the token farm dot stakers at the 0th index is going to be this account that we're using. We update our unique token staked, we update our staking balance, and then we add stakers.push, right? So we're going to be the first address in this array now. And then I'm going to do one other thing here too. I'm going to do return token farm and dap token. The reason I'm doing this is because now we can actually use this test in some of our other tests. Now we're getting a little bit integration-y here. We're kind of mixing and matching some stuff. We could even probably put this whole thing in a function in our regular scripts directory. But for simplicity's sake, this is how we're going to architect it. But great, let's test the rest of those. We'll just hit up, Brownie test -k, test stake tokens. We'll hit enter, and perfect. This is passing correctly as well. Awesome. Let's keep going. Now we're moving into this test issue tokens phase here. And we're going to use our test stake tokens test here. So the way that we're going to use this is we're going to grab this amount staked parameter, place it in here, and we're going to set this up exactly the same way. And we're going to set this up almost exactly the same way. So we can even just copy these few lines here, paste it. We're going to do an arrange. We're going to check to make sure we're on a local network. We're going to get our account, but instead of doing deploy token farm and dap token, we're going to do token farm, comma dap token equals test stake tokens, and we're going to pass it that amount staked. So this is why we're returning the token farm and the dap token in our test stake tokens. That way we can use that function now in our test issue tokens. And perfect. Now we can test issuing these tokens. So to test issuing tokens, to issue this reward, we want to first take some inventory of the current starting balances of our address here. So we'll say starting balance equals dap token dot balance of account dot address. And great. This is how we're going to start off in our arrange phase. Now let's move to acting, move in our act phase, and we'll just do token farm dot issue tokens. We'll say from account. And this is really the only thing that we're testing here. So now we can move into the arrange stage, and we'll do assert. I'm going to do a little parenthesis here because this is going to be a long thing. And we're going to assert that the dap token dot balance of the account dot address should equal the starting balance plus some new amount. What's that new amount going to be? Well, if we look at our issue tokens function, if we're staking in our conf test, if we're staking 1 ether, right, or 1 DAI, right, because we're staking the dap token, we're just staking 1, our mocks are going to be this FUSD price feed, right? Our mock V3 aggregator, when we deploy it, the initial value is going to be this 2000 right here. And we're saying in our mock, in our sample here, we're saying we are staking 1 dap token, which is equal in price to 1 ETH. So we should get 2000 dap tokens in reward. Since we're saying, since the price of ETH is 2000 USD. So there's a little bit of math here, but the initial value is going to be 2000, right? You can almost think of it like this, with 18 decimals. And our application pays us reward based off of the total USD value that we have locked. So we actually can know that this is going to be that 2000 price. So what I'm even going to do is and if this isn't already in the Chainlink mix, shame on me, I should add this in here, is we're going to add a new variable called initial price feed value. It's going to be equal to 2000. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. 1, 2, 3, 4, 5, 6, 7, 8. It's going to be that super big number. And we're going to take that and we're going to set that here to our initial value. Is going to be now this initial price feed value. And what we can do in our test is we can then import that from our helpful scripts. And we can just assume that our starting balance is going to be now our starting balance plus that initial price feed balance. And if we've done our math correctly, and if we've done our issue tokens, and if we've done all of our get value correctly, this should work. We should have done our testing already on the things like get user total value, right? Because get user total value is a subset of issue tokens, but we're jumping the gun a little bit here. And we're going to test this later on anyways. So with that being said, let's run this test. Brownie test -k, test issue tokens, and lovely. So our math is correct. Awesome. We are doing wonderfully with our tests here. We've even gotten some of the harder ones out of the way early, which isn't too bad either. Now, as far as this video goes, we're actually going to stop rating the test because we're literally just going to keep going down that Solidity file and grabbing functions and adding tests to them. We've got all the tests located in the GitHub repository associated with this lesson. There is both a unit test file and an integration test file in the GitHub repository. If you want to just go ahead and check that, feel free to do so. We're going to move on to the next section to keep things moving forward. But I highly, highly recommend you trying to write all these tests yourself. So good luck. We're going to have to make our
now we're going to move
file.
into
We're going to have to add our private key
and
and our
so
web.
before we run this, make sure that
Fira
your integration tests
project
work well. Make
D
sure that
to get started.
if you run your deploy
If you want,
script
you
on
can
an
copy
actual
paste
network
this
directly
directly
like
from our
Coven,
last
because that's what we're
project.
going to be testing, everything works
We'll
correctly.
say dot
So of course,
env
you're going to want to get out your
dot
.env file. You're going
Great.
to want to add that to your Brownie config. Add
Great.
private
Now we have
key in, add your Web3 inferior project ID, and make sure you have plenty of testnet Coven so that you can actually run these deploy scripts.
We can always find the latest faucets from the link token contracts page under our Coven or Rinkby networks here. We're also going to need our wallets section. We'll do from key, and this is where we'll put the $ private key. Because
now let's move into something
now that we've done all the
brand new
contract
here.
work, we're going to learn something totally new that we haven't covered yet. We're going to learn to do some front end development. Now, like I said, this isn't a front end course, and the focus isn't going to be on front end.
And I want to point out right away that this is considered a bonus section. There are a ton of pieces in this section that we're not going to have the time to go over thoroughly because we're not going to be going into what's going on the front end side. The editing is a little bit choppier, and I highly recommend having the documentation, having the GitHub associated with this front end with you while you're going through this.
FreeCodeCamp has an awesome video on doing front-end work. And if you want to learn more about React and TypeScript and some of the technologies that we're going to go over, definitely check out those videos after this. We're going to make this, though, so that you should be able to follow along with everything that we're doing. If you're not interested in front-end, feel free to go ahead and skip this part. However, understanding how these front-end applications work is really helpful, and it'll give you a massive, incredible skill to actually build front ends for your smart contracts. Having a really solid user interface is really important in the Web3 and the blockchain world. If people can't use your contracts, then what good is your application? So with that being said, let's jump on and let's build our front end. And I know we said we didn't like JavaScript. We're going to be working with TypeScript here, which is an improved version of JavaScript and catches a ton of the different bugs and allows us to be much more explicit with how we're working with our front end. We're also going to be working with React. We're going to be working with Create React App. This is a front end framework that allows us to quickly spin up a front end to build for our applications here. We're also going to be working with this tool called UseDApp. It's a framework for rapid dApp development and works great with React here. So let's get started building this front end. The first thing that we're going to want to do to build a front end for our full stack application, create React App boilerplate. So you should have npx installed. If you run npx --version, it should show up. This should be installed from when we installed npm. If you don't have npx installed, you can run npm install -g npx. Additionally, we're going to want to install yarn here. To install yarn, again, you just run npm install --global or -g yarn. You'll know you have yarn installed correctly if you can run yarn --version. You see a version of yarn. And I have a link to install both npx and yarn in our GitHub repo. But great, once you have those, we can actually create a folder with all of our boilerplate code in it. We're going to run npx create react app. We're going to call it front end. And this is going to create a new folder called front end. And we're going to do --template TypeScript, because we're going to want to work, like I said, with TypeScript instead of JavaScript. For those of you who've never worked with TypeScript before and who have worked with JavaScript, don't worry, the syntax is nearly identical. For those of you who have never worked with either, don't worry, we're going to walk through everything that we do. And then we'll hit enter here. And what's going to happen is you'll see we're going to create this new React app in this new front end folder in our project here. Awesome. Now that we've downloaded our Create React app, we have this new folder called front end, and it's got a whole bunch of stuff in it. Now, typically what different applications will actually do is they'll have one repository for all their Python and for all their contracts, but they'll additionally have a different folder or a different repository for their front end application and their front end work. This is really good practice. We're just going to bundle everything up into the same repo here just to get started and just to make it easier for us getting started here. However, what you will see across different projects is they'll have a totally separate repo for their front end. So let's take some inventory on what's actually going on inside this folder. So the first folder you'll see is node modules. These are basically the pip installs. These are the different packages pulled in from JavaScript and TypeScript. We can pretty much ignore this folder for the majority of what we're working with here. Next, we have our public folder. We're also not really going to go in here, but it's got some nice little images. It's got our basic index.html, which has the HTML that we're going to be running with. It has a couple logo images, and it has a manifest. The manifest is something that we want to change. This tells our browsers a little bit about what our app is and what our app actually does. So this is something that we would change, but everything in here is pretty self-explanatory. The short name of our application, the long name of our application, some icons, start URL. This is something that if you want to fiddle with it later, absolutely please go for it. And then robots.text. We're not going to talk about this at all. This helps web searchers and indexers learn a little bit more about your site. We can ignore this one as well. So for the most part, we're not really going to do anything in the public folder or the node modules folder. Our source folder, however, we are going to be spending a lot of time in. It has our app.css, which includes a whole bunch of formatting for HTML. We have app.test.tsx. This is going to be testing our front end. Yes, you can even test your front end. We're going to totally skip over testing the front end, which, yes, I know we've spent a lot of time testing our contracts. If you want to learn more about testing your front ends, there's some fantastic links in the GitHub and in the description to go over this. App.tsx, which we are going to be spending some time in, and it's one of the main places for us to write some code. Index.css, again, a formatting and styling file. Anything that ends in CSS is some type of formatting and styling. All these TSX are going to be TypeScripts. Index.tsx, we're going to pretty much ignore. We are going to change the logo, and we can ignore all these last bits here. A package.json. This file tells our project what dependencies it needs and Node.js packages it actually needs to get started. We have a README, which of course is a README. We have a TypeScript config, which gives us some options on how to work with TypeScript. We're going to ignore this. And then we have our yarn.lock, which is an auto-generated file. We're not going to touch it at all because Yarn is going to automatically create this. If you're unfamiliar with yarn.lock and unfamiliar with a lot of this stuff, don't worry too much about it. This isn't going to be a file you're really going to need to pay attention to. But okay, now that we've created the basic Create React app, we can actually go ahead and right now we can see what a front end would look like. So we'll cd to the front end. We'll run yarn just to make sure we have everything installed. What yarn does is it actually installs all of our dependencies. Anything in this package.json, yarn's going to go out and download these dependencies and store them into node modules. And then yarn.lock is going to tell us exactly what it downloaded. Once running yarn now, it just checks to see, it says, it looks like you already have everything installed. Because when we run create React app, it already goes ahead and downloads everything. But now we can just run yarn start. And if you want to know where this is coming from, if you go in your package.json and you look under scripts, these are the 4 different scripts that we actually run. Running yarn start runs this mpx react scripts start, which will actually start our front end. So we'll do yarn start. You'll see react script start. You'll see it says starting the development server. And after a little bit of time, we'll get something that looks like this. Edit source /app.tsx and save and reload. And this is a super simple front end. Obviously, this isn't at all what we're looking for, but we've now started a front end, which is fantastic. It'll say compiled successfully. It'll say you can now view front end in the browser. It'll tell you exactly where it's located on our local host, on the network, and it'll give you any outputs from the front end down below. So we're just going to stop the front end for now by hitting Command C or Control C and closing it down. Of course, if we reload now on the front end, it's going to be blank. But great. So we have a really basic setup for working with a front end. Awesome. If we look at an application like app.aave.com, you'll see they have like this really fun connect button that pops up, and they've got some nice user interface tools for actually working with the blockchain. We don't want to have to reinvent the wheel and build all these custom tools for doing this. So we're going to use this application called UsedApp, or this framework called UsedApp, which has a whole lot of these already built in. To get started installing, all we have to do is run this command right here, yarn add usedapp/core. So here in our front end, we'll do yarn add at usedapp/core. And this will go ahead and install all the UsedApp pieces into our front end so we can actually work with UsedApp and not reinvent the wheel with working with wallets and working with Ethereum and other smart contract applications. Awesome. Now we have that installed. We can actually go ahead and start building our front end now. What we're going to do is we're going to go to app.tsx folder and we're going to start in here. We're going to start adjusting some bits in here. So what we can do is we can do yarn start and we'll get our little React front end here. Now what we could do is we can go ahead and do something like change anything in here, right? See how this line says edit source.app, source/app, and save to reload. We could do, we change this whole line being something just like hello. We'll save it. It'll recompile. We can go back and now it just says hello, right? So this is how we can actually upload and update our front end. We have these wonderful return pieces here, these return sections here, which will return the HTML to actually render the front end. And this is also our starting point for allowing our application to be Web3 compatible. So if we go to this use dApp documentation, right, we go to our getting started section, we have a little example here that shows kind of what something should look like, right? But it's not exactly clear where we put all this code. So they do have this wonderful step-by-step bit. And this is probably the most helpful bit here. It says the first thing you need to do is set up dApp provider with optional config and wrap your whole app in it. So we're going to use these dApp provider tags, right? This is the open tag and this is the closing tag. And we just wrap it around our app. So we can see here, this whole thing right now is our app. So we could take this whole thing, delete it, right? And if we save right now, we can go and see our front end's going to have nothing. It's going to be blank. This function app here, that's getting exported, export default app, and this is getting rendered in this index.tsx. We have this cool little app HTML tag thing, right? But in any case, we want to wrap this whole thing with this tag here, right? So we can even just copy this, paste it in. I can do dApp provider, and then my VS Code even auto adds a second dApp provider here. We can delete this div class name equals app. I'll just put a little divider in here and just say hi. And at the top, we'll just import this dApp provider thing. Like what is this weird tag? We're going to import it. So we'll do import dApp provider from and use dApp/core. Now, if we hit save, we'll get this weird error saying, hey, property config is missing in our dApp provider. And that's because this dApp provider needs a config associated with it. So we need to add this config bit into this dApp provider. So we're going to do config equals, this first bracket says we're going to type in TypeScript, and this second bracket is saying we're an object here. So in this config, we're going to tell our application a couple of different things. So we're going to tell it what supported chains there are. What are the networks that our application can actually work with? The default value for supported chain in UseDApp is going to be mainnet, Reli, Kovan, Rinkeby, Ropsten, and XDI. Since we're going to be testing only on Kovan and Rinkeby, we could just do chain id.kovan and chain id.chainid is another term that we can pull right from our UseDApp/core. Right, and now if we wanted some other chain ID, we could just go ahead and put it in here, right? Like if we wanted to work with our ganache, we could just do 1337. If we wanted some other random chain, we could just put the other number in there, right? But chain ID.kovan is going to be 42, and chain ID.rinkeby is going to be, what is it, 3? Yeah, 3 or whatever it is. And this is all we need to get started working with a Web3, a blockchain compatible application. So let's go back, let's save, and we'll refresh, and now it just says, hi. How's it going? So we're going to spend a lot of time in this source folder. And since we're going to be here in a lot, let's do some cleanup just to cut down on the amount of fat that we have with that create React app. So app.css, we're going to toss this. App.test, yes, tests are great, but we're going to toss it. We're going to leave index.css. We do need index.tsx. We don't need this logo bit anymore because we're going to use our own logo. We do need this. We also need this. And since we're not running tests anymore, we don't need this, but I'm going to leave it in here just in case you guys want to later on go back and add some tests. Great. So now we're looking a little bit lighter. And in our app, let's just remove app.css. Let's remove logo.svg, logo.svg. Goodbye. Now, okay, so we're going to create what's called a component. We're going to create a header component. Now in React, components are basically where you put modular parts of your front end. And we're going to create one of these components is going to be our header component. To do this, we're going to create a new folder, call it components. And in here, we're going to create a new file called header.tsx. And this is where we're going to put our header stuff. And we're looking to make a little button up here, right? We're looking to make a little button in this header. So what we're going